Okay. Should I share my screen now? Just kind of like leave it there?
Why not wait for a moment?
Okay.
Until people, I think people are still
Sounds good.
are still entering.
And Claudia, if you want to share the link to the YouTube streaming on the chat, people who have Facebook accounts or Twitter accounts can distribute it further. Yeah, here is the link to the YouTube streaming.
Well, I propose that we begin. Welcome all to the Princeton-Bucharest seminar. And today we are going to be talking about Newton on hypotheses. The two speakers are going to be Arends Palaio from the University of Illinois and Kirsten Walsh from the University of Exeter. And Arends is going to begin. So now why don't you share your screen? Perfect.
You are muted. You have to unmute yourself.
Thank you. Hi, everyone. I'm Arends Palaio. I am a PhD candidate at the University of Illinois at Chicago. And today I'm going to talk about the metaphysical and empirical criteria in Newton's hypotheses. Okay. So this is an outline of my talk. I'm first going to talk a little bit about motivations and what's at stake. And then I will present my guiding question and my working answer to this guiding question. From there on, my answer kind of consists in 4 parts, and that'll be the main chunk of this talk today. So those are the 4 main chunks there. And then lastly, I'm going to kind of summarize the main points that I try to defend in today's talk. Okay, so some commentators believe that hypotheses had no place in Newton's scientific thought, and indeed, Newton disdained hypotheses in many places. So in an unsent draft to Roger Coates, Newton writes that hypothetical philosophy consists in imaginary explication of things and imaginary arguments for or against such explications. In Query 31 of the Optics, Newton writes that hypotheses are not to be regarded in experimental philosophy. And in the General Scholium of Book 3 of the Principia, he proclaims to feign no hypotheses concerning gravity's cause, and that hypotheses, whether metaphysical or physical or based on occult qualities or mechanical, have no place in experimental philosophy. Okay. However, elsewhere, Newton does suggest that hypotheses do have a place in his theorizing. In an early letter to Oldenburg from 1676, Newton writes, "For the best and safest method of philosophizing seems to be first diligently to investigate the properties of things and establish them by experiment, and then to seek hypotheses to explain them, for hypotheses ought to be fitted merely to explain the properties of things and not attempt to predetermine them, except insofar as they can be an aid to experiments." Later on in the same letter, he begins disdaining hypotheses again, but I mean, this is the passage where he explicitly is saying hypotheses have a place in his theorizing. In the editor's preface, the 2nd edition of the Principia, Coates writes that Newton's class of philosophizing, which is the experimental philosophy, does not contrive hypotheses, nor do they admit them into natural science otherwise than as questions whose truth may be discussed. And then lastly, in a 1715 work, in an anonymous work, he writes that in this philosophy, hypotheses have no place unless as conjectures or questions proposed to be examined by experiments. Okay. In addition to this, kind of conflicting remarks that Newton makes, there are at least two ideas that Newton throughout his career tinkered with, but he never really fully admitted them as being a theory or a quam proxime truth, where quam proxime is that which is deduced from phenomena and made general by induction. And these two ideas are the ether and the corpuscularity of light. So the guiding question is, how should we make sense of these seemingly conflicting remarks about hypotheses? Some commentators do acknowledge that Newton used hypotheses, and these commentators haven't done much to articulate what permissible hypotheses were for Newton, which is what I'm going to try to do today. My answer to the guiding question is that we should understand the hypotheses that Newton rejects or disdains as Cartesian hypotheses, and the ones that he admits as viable hypotheses for him, so uniquely Newtonian hypotheses. And this kind of involves explaining what Cartesian hypotheses are, which is a very loaded question. So I'm just going to provide a stipulative definition of a Cartesian hypothesis, and I talk a little bit more about this toward the end of the talk. But basically, I'm going to assume the following definition of a Cartesian hypothesis, namely propositions that don't go against any logical principles and don't need to take into account the way the observable world actually is. Okay. And so what counts as a permissible hypothesis for Newton, I'm going to propose 6 implicit criteria that these two hypotheses satisfy. And these two, the ether and the corpuscularity of light, I'm going to first, in the first part of the talk, I'm going to suggest that we should understand them as hypotheses. And then the second part of the talk is kind of unraveling what implicit criteria are there and suggest that that is what makes them uniquely Newtonian hypotheses. And my proposal combines the partial pictures of Cohen, Dobbs, Janiak, Shapiro, and Walsh. Okay, so this, again, this is like a 2-part talk. I first provide a brief chronology of Newton's writing on the ether and the corpuscularity of light to show that these ideas are hypotheses. And then after, I propose the 6 criteria. I believe that there are 4 metaphysical criteria: non-contradiction, parsimony, loose mechanism, and divine conformity, and 2 empirical criteria, which may be called the analogy of nature and experiment. Okay, so a little bit more about these criteria, brief definitions. The first one is that they must be free of contradictions. The second is that they must be simple. The third is that they must be compatible with all action being contiguous. The fourth is that they must conform to Newton's notion of God. The fifth is that nature behaves in analogous ways in different contexts. And the fifth is that they have empirical support via experiment or observation. Okay. And I'm going to provide in the second part of the talk textual evidence for each of these criteria with respect to the ether and the corpuscularity of light. Although I grant that there are more than just 2 hypotheses in Newton's thought, I focus on these 2 since he seemed to be committed to them in a certain sense throughout his whole career, but they never really reached the level of being a quam proxime truth or experimentally certain or anything beyond that. So it seems like they're in the realm of probable propositions, we can say. Okay, so this is the timeline, the chronology of these 2 theses and his thought that I'll briefly cover now. So I'm first going to start with this text or in philosophical questions in 1660. And then I will discuss an alchemical text of nature's obvious laws and processes from 1672. I will discuss his paper, A Hypothesis, from 1675. And then another alchemical tract from 1687. And then we get into his later era, around or after 1713, and an interleaved copy of the second edition of the Principia. So it has to be after 1713. And then lastly, the third edition of the Optics. Okay, so in this 1660 tract, he says the matter causing gravity must pass through all the pores of a body, and that the stream descending will grow thicker as it comes nearer the earth, but it will not lose its swiftness until it finds as much opposition as it has help from the flood following behind it. So the matter, so here he's kind of presenting like an ethereal vortex theory, pretty similar to Descartes. The spirit, this ether, was heavy, it had weight, and it pushed things around. And it's not surprising that early Newton was committed to this. A lot of people at the time, except I guess a good chunk of people at the time, did understand the ether as being a material substance. As for the corpuscularity of light, his remarks with respect to that in this tract is whether the rays of light may not move as a body, may not move a body as wind doth a mill sail. So he's making an analogy between the behavior of rays of light and the windmills. And this indicates that he thought light acts like a body similar to air. In his 1672 piece of Natures, he writes that aether ought to descend as air, and exhalations and ascend, and therefore the ether, being by many degrees more thin and rare than air, should move around and descend more quickly. And that's a typo, that should say 1675. In his work, A Hypothesis, about light, he writes, where he suggests that light consists of multitudes of unimaginable small and swift corpuscles of various sizes, springing from shining bodies at great distances, one after another. Okay, and now we kind of get into the 1680s, where things, at least with respect to the ether, seem to go a different direction. So Newton's commitment to and conception of the corpuscularity of light remains fairly unchanged until the end of his career, but the same cannot be said about the ether. Newton's commitment to the ether was periodic, and the precise notion that Newton had of it underwent significant revisions around the 1680s. Newton's intense research into planetary motion, which culminated in the form of an essay, De Motu Corporum in Gyrum, and this contained the central pieces of what would eventually be published in the Principia. By 1687, Newton had a very clear idea of centripetal force, Kepler's laws, and planetary motion, that an ether existed and pushed the planets around, as the traditional vortex theory suggested, would have been confirmed by the resistance of planetary bodies, of which there was no evidence. And he even suggests that he conducted these pendular experiments, which disconfirmed this idea that a material ether existed. Okay. However, at least his alchemical, in his alchemical writings and projects, we still see the ether kind of appearing. So Newton provided a translation and summary of an alchemical book, La Lumière sortante des ténèbres. One passage he translates and paraphrases refers to the vapor of the elements, which is very pure and almost insensible, and contains in it the spirit of fire or light, which is the form of the universe. So Newton's reproduction of this material falls very short of actual endorsement. Nevertheless, some passages suggest that Newton remained committed to the ether. So I like to think that, he kind of picked and chose what to summarize and what to translate And I think it's significant that this passage on the ether stood out to him. And he could have still been tinkering with this idea of the ether, even though his astronomical works have kind of disconfirmed one version of the ether. Maybe he's looking into other versions. It's clearly still on his mind, I believe. Around or after 1713, in an interleaved copy of the second edition of the Principia, he writes the following, which turns into a passage which would appear in the third edition of the Principia, but it's a cleaner and I guess like more non-committed version of this passage. So he says, it would be possible to add not a little about a certain very subtle substance pervading dense bodies and lying hid in them, by whose force and actions the particles of bodies attract each other at the very smallest distances, and which, when they are brought into contact, causes them to cohere, and by the spirit electrified bodies act at greater distances, both attracting and repelling little objects in their vicinity. So here, the ether has different properties than the ether we saw in the 1660s. So it's elastic, it's electric, it pervades dense bodies. Okay. And then lastly, in the 1727, 1730s, he passed away in 1727, but this book was published in 1730. So in the third edition of the Optics, he again mentions the nature of light and his belief that light is made out of corpuscles, are not the rays of light, very small bodies emitted from shining substances. In Query 21 of Book 3, the ether reappears. It mentions the ether's variable density as the cause of light raises inflections. Here he rhetorically asks, is not this medium exceedingly more rare and subtle than air, and exceedingly more elastic and active? And doth it not readily pervade all bodies? And is it not by its elastic force expanded through all the heavens? And the ether appears in other queries as well. Okay, so that was the first part of the talk. I kind of went on a brief chronology of these two theses in his works. And I think, it's pretty clear he doesn't believe that they're absolutely true. They definitely fall short of a quam proxime truth, but he's still tinkering around with them. So he seemingly believes that they're probable propositions. He's working with them in a certain sense, especially because they appear in his published works. So I'm going to take it that, these might be Newtonian hypotheses. These might be viable, permissible hypotheses for Newton. And so now I'm going to look at what implicit criteria are in these two theses. Okay. So I propose that there are four. There's non-contradiction, that a hypothesis should be free of contradictions, parsimony, nature does nothing in vain, and more causes are in vain when fewer suffice. For nature is simple and does not indulge in the luxury of superfluous causes. That's over here, but this is Andrew Mott's translation, so it's a little different. Mechanism or loose mechanism, and this is taken from Andrew Janiak's 2008 work, which is a thesis that forces are allowable, but any change among material bodies has to be contiguous. There can be no change or action at a distance, basically. This is going to be the more controversial one, as well as this fourth one. So these are the two that I'm going to focus on. The fourth one is divine conformity. And the basic idea is that hypotheses should conform to Newton's conception of God, a necessary, existing, all good, knowing, and powerful being from whom the world emanates. Okay. So yes, I'm just going to focus on 3 and 4, since the first two are pretty uncontroversial. Okay. So here's some evidence that Newton may have been committed to a loose mechanism. I am thinking about maybe loosening this loose mechanism a bit more, something I'm still working on and fine tuning. But my evidence for at least this version of loose mechanism is this letter to Bentley, which is pretty controversial among some Newton commentators. Some commentators think that what Newton said to Bentley may not really be indicative of his true views. But I'm not. I tend to think that we can get something informative from this. So Newton commented on the following on action at a distance: that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance, through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. So he dismisses the idea that his theory of universal gravity entails action at a distance. It's pretty strong language, and elsewhere in corresponding with others of his contemporaries, he makes similar remarks, which left the possibility that all action involves contact with a very subtle, perhaps infinitely tenuous medium, namely an ether. So some evidence for divine conformity. So before I talk about divine conformity, I want to just say that the reason why I don't talk about the corpuscularity of light is because the thesis of light's corpuscularity already involves it's already compatible with the idea of mechanism. So that's why I don't really talk about it here, even though I do in the paper version of this talk. So divine conformity, I have not really found much evidence for Newton kind of relating his conception of God with light. So if anyone out there who might know something more about this, find something, I'd appreciate if you send me an email or let me know. There is one example in the early alchemical work of Nature's, where he kind of connects the two. But otherwise, I've only found evidence of the ether being in conformity to Newton's notion of God. Okay. So what is Newton's notion of God? Roughly, it's the idea that humans have no idea of the image of God. God is not corporeal in any sense, and he should not be worshipped in any form of idols. Yet God still exists. And while he is not identified with space or time, he is eternal, infinite, and present, for God is one, present everywhere virtually and substantially, contains all things, but he remains causally independent. That's pretty important. Another instance worth mentioning briefly is when Newton corresponded with David Gregory and Richard Bentley concerning God and the natural world, particularly with respect to the Principia and Newton's theory of universal gravity. Because God does no action that can be done through another, Newton admits to them that a divine intermediary agent is at work in the cosmos and maybe this underlying cause of gravity. So he doesn't explicitly say the ether, but he allows that this divine intermediary agent is at work. And I think if we put it in context with what he says about the ether, especially his later comments, it seems like this ether could be some kind of divine intermediary thing that could be an underlying cause of gravity. Okay, so that's the metaphysical criteria. So I discussed how light's corpuscularity and the ether kind of implicitly involve mechanism and divine conformity. Okay, and now I'm going to talk about the empirical criteria. So these criteria are empirical in the sense that the main import they supply is directly from the world, either by analogy, observation, or experiment. But they do differ with respect to how much empirical import they supply. So this is the thin one, the analogy of nature. Excuse me, that nature is always simple and ever consonant with herself. This is the idea. The consonants part is the piece that, I guess the conjunct that I focus on, because that nature is always simple, deals with parsimony. So the consonants is the part that kind of hooks up to this analogy of nature criterion. And experiment. What this criterion expresses is that viable hypotheses should have observational support, where observational support means simple yet deliberate observations, including careful experiments, as well as more robust deductions from phenomena that are not refuted or contradicted by other carefully obtained evidence, and that provides support. So I word this in a way such that it definitely falls short of deductions from phenomena that are made general by induction, because I take that to be, for Newton, what is a quam proxime truth, or kind of the highest truth that you can obtain in the natural sciences. Okay, so evidence of the analogy of nature. So in a hypothesis, he says, I suppose that as bodies of various sizes, densities, or sensations do by percussion or other action excite sounds of various tones and consequently vibrations in the air of various bigness, so when the rays of light, by impinging on the stiff refracting superficies, excite vibrations in the ether, which I suppose affect the sense. For the analogy of nature is to be observed. And he talks about this analogy of nature a few times, and especially so here. So Newton also describes the behavior of the ether as analogous to other parts of nature. In most of his early works and in a post-1713 short essay, De Dialectrica, Newton describes the ether as if the medium were fluid. In an earlier alchemical essay, he claims that the earth resembles a great animal, or rather an animate vegetable, which draws in this ethereal breath for its daily refreshment and vital ferment. In De Dialectrica, he writes that the ether is a vehicle for transporting the impression of light into the brain. So when he discusses the ether here, he's drawing analogies from actual processes that he can observe. Similarly, in the previous quote on light, he's doing the same thing regarding the behavior of light. Okay. So now the experiment criterion. So with respect to the corpuscularity of light, query 29, he asks, are not the rays of light very small bodies emitted from shining substances? To give some credit to the idea that light is a body and susceptible to attraction between bodies, which is a kind of Lockean notion of substance that he accepts. He says the following, the rays of light in going out of the glass into a vacuum are bent towards the glass, and if they fall too obliquely on the vacuum, they are bent backwards into the glass and totally reflected, and this reflection cannot be ascribed to the resistance of an absolute vacuum, but must be caused by the power of the glass attracting the rays at their going out of it into the vacuum and bringing them back. So in the optics, he performs a bunch, well, it's suggested that he has performed a bunch of experiments, and this is just one instance in which he thinks that the results kind of support this idea up here. So the experiment criterion with respect to the ether, in De Aere and Etherae, he notes that air particles are a result of bodies that break up into smaller particles. And if this is the case, then air particles can be crushed into subtler parts. He continues by saying that if this little air can enter the interstices of materials such as crystals and glass, then it is subtle enough to consider it the spirit of air, the ether. This falls a little bit short of an experiment because he's just describing how crushing particles, you get smaller particles. But in the next slide, which this picture kind of is about, we see more robust experiments. I'm only going to talk about the one to the right here, but he also discussed an experiment that Boyle performed, where he talks about these spirits and magnetic effluvia, which sometimes he connects to the ether. But in the quote that I want to focus on, this is from De Electrica, a tract that contains near identical writing to the general scholium of book 3 of the 3rd edition of the Principia, and it references propositions from book 1 of the same text, as well as his optics. So Newton refers to and describes some experiments, which I believe suggests that this experiment criterion was something that a viable hypothesis, the ether in particular, should satisfy. So the ether in this tract is not only electrical, it is also the cause of electrical attraction, and not only reflects, refracts, and reflects light, but also emits it. And it is manifest from the following, experiment. A glass globe 7 or 8 inches in diameter is exhausted of air and rotated very rapidly upon an axle. If the hand kept stationary is rubbed against it, it emits the electric spirit, which will shine from the place where the fingers are into the interior of the glass. I don't know exactly the picture I should be envisioning when this experiment happened. If anybody in the audience might know more about this, I'd appreciate, I guess, you speaking up and letting me know, or if this interests you, I'd be happy to work on what's going on here exactly. It sounds like, I mean, like an extreme form, it would be like a plasma ball where you put your hand and there's like a spirit or like some kind of electrical kind of output there. But I'm guessing that maybe the image is more like this. There are like little sparks. And this is like from a YouTube video on the Tesla coil. So it's a vacuum and there's metal coils in the middle. So yeah, there are some differences, and I'm not, and this is definitely an experiment in which she's talking about the ether. And I guess I'd like to know more about what exactly to picture here. So if anyone has anything else to say in addition here, I'd appreciate it. Okay, so now I'm wrapping up this talk. And I'd like to talk about briefly some differences between Cartesian and Newtonian hypotheses now given the first part and the second part of this talk. So what are Cartesian hypotheses? That's a really big question. And it's currently, I think, debated in the literature. For this paper, I stipulate that Cartesian hypotheses are propositions that are conceivable, do not go against any logical principles, and do not need to take into account the way the observable world actually is. And this is based off of Desmond Clark's occult powers and hypotheses. So given what I've said, I think the difference between Cartesian and Newtonian hypotheses is that the latter should satisfy not just non-contradiction, but it would also have to satisfy a particular version of mechanism, and it needs to conform to Newton's conception of God's being in the world and to fairly specific empirical criteria. So given my presentation here, Newtonian hypotheses are propositions that meet the following 6 criteria. Okay. And quick summary, the guiding question was, how do we make sense of the seemingly conflicting remarks in Newton, where he disdained hypotheses, but seemingly also accepted them? My answer involved articulating what permissible hypotheses were for Newton. I first proposed 2 theses that I believe were hypotheses in his thought. And then I argued that there are 6 implicit criteria in Newton's hypotheses. If that's right, then we should understand those hypotheses that Newton rejects as Cartesian hypotheses, and the ones that he admits as Newtonian hypotheses, or ones that he considered permissible. And I focused on two ideas that he tinkered with to first support the idea that those two ideas were hypotheses, and that's it. That's the end of my talk. Thank you so much. I'm sorry if I went over time. Okay.
Dan, you're muted.
I'm sorry. Now I'm unmuted. Thank you very, very much. If there are any questions, if you could use the raised hand function in the program, that would be very helpful. David Miller.
Hi, can you hear me?
Yes.
Okay, great. I just had thank you very much for a nice talk. I just have a sort of basic question. When you say that the hypotheses are permissible, right, you're talking about a boundary that they're permitted across. And so I'm just curious which boundary you're talking about here. And this is getting into the question of whether there's 1 Newton or 2 Newtons. And because, right, one thing that my own view is that, well, I think it's pretty clear that Newton is trying to set up the experimental philosophy, right? And that's something distinct from the natural philosophy more broadly. And so the question is, when you say is permissible, is it permissible? Is it permissible within the experimental philosophy, or is that what we're talking about here? Or is it permissible with natural philosophy more generally? Right? Is it permissible as like a working hypothesis that might then get promoted to become part of the experimental philosophy? Just what's permissible as what? That's the, sort of which boundary is the permission granted for the hypotheses to be entered into?
Yeah, thank you. Thank you so much for your question. That's a really good question. So I haven't really looked too much into what exactly the experimental philosophy means for Newton. I guess if it's something that is very specific to his physics, I would say that the hypotheses I'm talking about would not be, so would have a larger scope than just his experimental philosophy. Because I guess like an underlying more background thing that I'm doing here is also thinking of Newton not just as somebody who works in physics specifically or just optics, but he at the same time is like simultaneously working in different projects in alchemy and his theology. And that is where some of these that is what inform some of these criteria. Yeah, does that help answer your question?
Yeah, that certainly helps.
Okay.
But of course, that's where the one and 2 Newton stuff comes into play, because, right, the experimental philosophy might be, depending on what your views on this are, might be constrained to the physics and the optics, and then the other stuff might be outside of that. The more alchemical, speculative Newton might be outside of that, depending on how he's conceiving of his own disciplinary projects. And so it would be helpful to work out more clearly like what boundaries we're talking about here.
Yeah, I guess in a sense,
helpful.
Yeah, I guess in a sense they could be, so they would be in the experimental philosophy, they definitely fall short of what would be considered a quantum proximate truth. So that in that sense, they would be, I would argue they would be hypotheses in that sense. And the things that satisfied the criteria I propose would be hypotheses in that sense as well.
Okay, Vincenzo De Risi.
Yes, thank you very much for the talk. I enjoyed it very much. I've just an explanatory question. That is to say, could you say something more about your fourth criterion, that is the connection with God? My question is how this should constrain the hypothesis made. I mean, the other criterion are quite straightforward on this point. I think a hypothesis must not be contradictory. A hypothesis must be simple and so forth. But what do you think that it means practically to conform with Newton's idea of God? That is to say, what hypothesis could be ruled out by that? Leibniz, for one, was someone who brought God a lot into physics and natural philosophy by appealing to some kind of architectonical principles, which were indeed very strict for him. But is Newton anything? I mean, what do you think that Newton thought about that? That is, which are the physical constraints?
Okay, thank you for your question. So as I understand it, there might be two parts to this question. So the first one is, how is this criterion of divine conformity constraining? I think you said physical sense, but I'd argue that it's metaphysically constraining, and I'll say why in a moment. And then you had the other question was textual evidence, where he actually refers to God in order to maybe reject someone else's thesis and propose his own. So as to the first question, I would say that the four metaphysical criteria are metaphysically constraining. So they're metaphysical in the sense that they constrain what is actual and what is possible and what's impossible. Whereas the empirical criteria kind of already assume the natural world, and they're more constraining about, they do more of the physical constraining work. So that's one part of your question. The second part of your question, as for textual evidence, I won't be able to, quote Newton off the top of my head here, but if you look at Descartes, he does refer to his conception of God in order to argue against Descartes' conception of matter and extension. And so that's where I realized this, there's something going on with God here in what Newton conceives is possible, and might have an influence on how physics and his natural science works as well. Does that answer your question?
Yes.
Okay. Thank you so much.
Great. Michael Jacobidis.
I'd like to talk. I really want to form this question in the form of a question, partly because of the nature of the question. So I think that you've got good criteria for separating out hypotheses that Newton would think are good and ones that he thinks that aren't. I think maybe that's not the hypothesis non-fingo versus. So a couple of the passages that you quote near the beginning say hypotheses are fine for raising questions. And so you might think, look, in the Principia, he's making assertions, and in the body of the optics, he's making assertions and justifying them. But then, we want to raise hypotheses also in other contexts as propositions to test, and it's fine in its place and in its form. So here are two questions. One is, do you take your reading to fit with those initial passages that you quoted saying hypotheses are fine for raising questions? And second, you took a couple passages from the Queries of the Optics and say, these are rhetorical questions. And I kind of thought, no, right? That the queries are the permissible form of advancing a hypothesis. and it would be sort of twisting things to change them into assertions. So the second question is, are you sure that you think of the queries as rhetorical questions? That is, I think, as disguised assertions.
Yeah, thank you so much for your questions. So I'm gonna start with your first question first, and then I will address your second question with respect to whether or not the queries are rhetorical. Maybe only some are. I.B. Cohen is the one who discusses, the rhetorical. I think it's him. It's discussed in the literature about the extent to which they are rhetorical. But first question. So, do I take my reading to fit the initial readings? I kind of understand this as a question about continuity in Newton. Does Newton change his views at all about hypotheses? And I can see that they do. I mean, I can believe that they do. I think he does change his mind. There is a shift in his thinking, especially with respect to the ether, right? The corpuscularity of light, I would argue that there's an earlier shift in his thinking about that, just because in the beginning he believed he was proposing a theory, but then he changed it to his hypothesis. And so I would say that there is a shift in his thinking. So it could be that maybe some of the criteria don't apply to his earlier, really early readings, partly because he thought, he kind of thought that, conclusions of science could be demonstrably certain, as opposed to, something more moderate, like a more moderate certainty. So I'll say that for the first question, and then the second one, it's kind of up for debate on whether queries are rhetorical questions or not. Some commentators think that some of the queries are rhetorical, and they've identified a way of discerning which ones are rhetorical or not by kind of doing like some linguistic work on how Newton phrases the questions themselves. This is kind of the next. So I'm working on a paper on what kind of role the queries have, and just the role of hypotheses later on. But I guess in content, if we look at the queries and just in content as opposed to maybe like what role they have, I would argue that that at least some of them are expressing hypotheses for Newton.
I guess I was suggesting that they were all expressing hypotheses for Newton, but in the permissible form, which is the form of a question.
Okay, yeah.
The first question was about some passages you quoted at the beginning saying hypotheses are fine when they're for the sake of raising questions.
Okay. So whether so I do think that that what I'm arguing is consistent with his having said that hypotheses are admissible only if they are posed as questions. Just because I'm not talking about the role, right? The kind of like any kind of functional role hypotheses have. I'm really just talking about what, where he talks about them, whether they are in the form of a question, or maybe he just happens to, say it in a more declarative form. So that I guess that's the kind of distinction I'd like to make there, is that I guess thinking about what he says, the permissible, hypotheses are permissible if posed as questions. I guess the posing as questions is more about how they're used, whereas I'm examining just the content, I'm looking at those usages where he does pose them, where he does talk about these things in questions. And that's where I kind of, okay, so that's where I kind of adopted like, okay, well, the ether and the corpuscularity of light theses both show up in his queries. So they, that would just be like an additional reason for thinking of them as hypotheses. And then the criteria is more just about like the content of these two theses in his thought. And I guess not so much about, I mean, there is that further question of, like you can use them correctly and incorrectly, like these two hypotheses, in which case you could feign a hypothesis. And I haven't talked about that. That's like a whole nother area, but I hope I kind of addressed your question there. Okay.
Thanks.
Thank you. Yeah.
Great. Terry Bristol. You have to unmute yourself.
Okay, I think I'm unmuted now. Yeah, so I've thought about this question a lot. It bothered me. So, and one of the ways I had kind of approached it, I think first of all, you did great talk and really nice coverage of the issues. But one is, what is he actually saying, and why is he saying it, and who's he saying it about? So it's sort of like when he's saying, "I do not feign hypotheses," so forth. What he's doing, I think, is he's critiquing some other people who kind of think they're doing physics or science. And the primary target, I think, is actually Descartes, which I think you have in mind, or you've covered essentially. And I've just been, when Newton got finally adopted onto the continent, so the French kind of dealt with him. And I think that, I think Leibniz is aware of him. Of course, the Leibniz-Clarke debate, I would really wonder where hypotheses came into that. Anyway, I think the fundamental thing, which you've identified, is your experiment thing. That what Newton's saying is that hypotheses should come from empirical work to begin with. And you can ask us a question about that. Where they shouldn't come from is what Descartes does. So principles independent of experience. Okay, so he's really going after, I think that the critique, what he's saying and who he's arguing against is Descartes. Now, other people do that too, reasoning from, biblical things or so forth. In particular, I've been looking at Lazare Carnot, who you might look at. He's very, in his fundamental principles of equilibrium of motion, he's very explicit about this. And he says, like, forget this reasoning from principles. We're going to start with, finding out things that work empirically. And once we figure these out, we got, that works. We figured it all empirically. Then we can apply the algebra. Then we can reason about them in terms of an analytical framework. And I think he's picking it up a bit from the Newtonian, movement that had come out of the continent. And the basic idea is you can mess around all sorts of questions and hypotheses and anything, as long as you're in the empirical context. As long as you're doing experiments, questions, so forth, all sorts of that. And but one last thing, I'm trying to remember this, Hewell or maybe Dan would remember this, but somebody really misinterpreted Newton, and it had to do with earthquakes. And the idea was you should just go out and gather all the data, get all this data and gather it. And then from the data, you would be able to come up with hypotheses, but you shouldn't have any hypotheses to begin with. And I think it was Hewell or whoever it was looking at the theory of earthquakes. And he concludes in the end, like, this is completely stupid. You have to have some hypotheses in order to do your empirical work to begin with. But those are empirical hypotheses. They're not, like from a priori principles. But anyway, it was one of the misleading understandings of Newton's "I do not feign hypotheses." Like, we want all people like Newton, so just go out there and look at the world, and things are going to pop up on you. Yeah, it didn't work. Anyway.
Yeah, thank you very much.
Yeah. I'm afraid I don't know who it is that said that, but in any case, Adrian Curry.
Thanks. I'd like to sort of add my voice to the chorus of people who want to hear more about permissibility. And I think your back and forth with Michael was really helpful to me, because I kind of felt as if when you're talking about sort of epistemic criteria, it's really important that I know the function, right? In order for me to understand why that epistemic criteria is relevant, I need to know relevant for what? Relevant for assertability, relevant for putting on the table, relevant for playing around with, relevant for discovery, relevant for justification, you know, some of those things. And I thought it was really interesting that your response to Michael was like, oh, I'm pulling apart the kind of content from the epistemic function. And I guess my immediate reaction was something like, well, isn't the whole point of permissibility when we're talking about epistemic criteria that they're permissible for some function? And so I guess I found myself kind of suspicious of the idea that you're able to make sense of those criteria without thinking of them in terms of the epistemic function that Newton has in mind. So that was phrased less as a question and more of an objection. So I wonder, like, do you have a story about the function that can help me then understand, or do you think you can kind of descriptively list these criteria and then downstream you'll be able to attach them to the functions? There, I made it a question.
Okay, thank you. Yeah, so I agree that so I guess the reason why I'm pulling them apart is really just maybe for her heuristic purposes, because in Newton themselves, they're intermingled all the time. And I guess my approach is just to detangle them for heuristic purposes and to discover maybe a little bit more about what's characteristic of hypotheses for Newton. I do have a story about the role of hypotheses. It's very much an ongoing project at the moment. But I will say that I think with these criteria come with at least these two roles, namely that they have to serve as an underlying mechanism for an event, and they are tools to move science along. And I think those are kind of the two main epistemic roles that the hypotheses have. I'm not sure if that is satisfying to you.
Yes, that helps. So I take it from me,
Okay.
what I'd want would be then a connection in like Newton's sort of reasoning between why those criteria are the things that matter, given that he has those aims in mind, would then kind of make it look really plausible and neat to me.
Okay. Yeah, I guess because I argue that these are kind of implicit in Newton, I am not saying that he explicitly, thinks that, he doesn't explicitly say these criteria need to be met. These are kind of implicit in what he suggests. Although, yeah, I think with maybe a bit more work, I might be able to do some more connecting that you're looking for in Newton with respect to the function and the role and these criteria. Thank you.
Okay. Russell Wall.
Yeah, can you hear me?
Yes.
I think I've unmuted myself. Thank you very much for the talk again. I wish I'd had more of that when I was teaching Newton a while back, but it's very helpful. But my question actually has more to do with the picture of Descartes that is used in this contrast here. And I'm careful having Dan Garver here, but nevertheless, it does seem to me that actually that Descartes, what I'm trying to think of where we're talking about Descartes' hypotheses. And I'm thinking about the way that Descartes uses hypotheses, for example, in the world and some of his other, his discussions of light and everything. And I see actually some more of the criteria that you put on the one side there than in fact Descartes had. And so I'm curious about a couple of things. One is, does Newton himself, I wish he talked a little more about which hypotheses he was criticizing, because you have to supply some of that. But I wondered if he had any specific hypotheses in mind. Now, I understand he doesn't like the Cartesian method, as we've already heard, he doesn't like, for example, Descartes' argument that the essence of matter is simply extension and motion, but it's hard to see that as a hypothesis the way that Descartes sets this up. That's not, he uses hypotheses to explain, the mechanisms in things in the human body and stuff like that. And it does seem to me that he's actually, that this picture is, doesn't actually cover Descartes' actual hypotheses. That is the contrast that you're making between the good hypotheses and the bad hypotheses. So I just wondered if there was some place where he actually talked about the actual hypotheses that were involved, and if there was or if there's some particular kind of hypothesis that Descartes using in some of his works that I just don't know enough about Newton to.
Yeah, that's a really good question. So in a longer version of this talk and paper, I'm going to include a discussion on Cartesian hypotheses, and I'm going to focus on the hypothesis that Newton explicitly rejects in Book 2 of the Principia, the Cartesian vortex matter theory. So that's at least one way in which he definitely uses that term, and he rejects that hypothesis. There are some other, I think, instances in which he uses this term. Kirsten Walsh might know a bit more. I know, I don't know if she might know like other specific instances of Cartesian hypotheses for Newton, but I think it's something that's definitely needed in the current Newtonian scholarship is, figuring out what exactly Cartesian hypotheses were for Newton and what specific propositions he kind of tied to that phrase. So thank you.
I would add just briefly, that was a question that I would have raised had there been time, because I think that there are a number of different ways in which Descartes talks about hypotheses, and I think it might be interesting not only to ask the question, what are Cartesian hypotheses for Newton, but also what are Cartesian hypotheses for Descartes and for the Cartesians. But that opens another line of discussion. Thank you very, very much, Lorenz.
Thank you.
And now I think we'll move directly on to Kirsten Walsh. Do you need to share your screen?
Yeah, I will. Okay, I guess I'll begin. I should warn you, I have a bit of the freshers flu that has been going through our university. So I can't guarantee my voice will last the whole time, but we'll give it a good go. Okay, so my talk, I guess, builds on Arendt's work in maybe in an interesting way. I'm going to talk about the roles of hypotheses as opposed to the criteria for permissibility. So early modern experimental philosophers often appear to commit to and utilize the corpuscular and mechanical hypotheses. And together these hypotheses seem to set explanatory constraints for natural philosophy. And this, might seem surprising given experimental philosophy's methodological emphasis on experiments as the foundation of natural philosophy and its rejection of speculations, fancies, and hypotheses. Take Newton, for example. Newton, as we've already seen, introduces a corpuscular hypothesis in his optical work, coupled with an ethereal hypothesis. It provides an underlying mechanical metaphysics that illustrates the theory, making it kind of intelligible and compelling. And yet he declares in various methodological passages that hypotheses are not to be regarded. And so we have, for example, this one here at the end of the optics. He says this analysis consists in making experiments and observations and in drawing general conclusions from them by induction and admitting of no objections against the conclusions, but such as are taken from experiments or other certain truths. For hypotheses are not to be regarded in experimental philosophy. And of course, he follows a similar pattern in the Principia, where we see hypotheses of various kinds, and yet he declares hypotheses non fingo, and so on. In this talk, I'm going to argue that while hypotheses are certainly not the goal of Newton's investigation, so they're not an end in themselves, they nonetheless play vital supporting roles in Newton's natural philosophy. So in this talk, I'm going to look at a couple of examples of how Newton uses hypotheses, and so draw out the main features of the use that they are put to. Newton's optical work is revelatory, I think, of his attitude towards hypotheses. That is his attitude towards speculation on the underlying nature of things. Okay, so first I'm going to briefly articulate what I take to be Newton's distinction between theories and hypotheses. And then I'm going to go through a fairly detailed case study that involves Newton putting corpuscles to use. And then I'm going to finally conclude very briefly with some lessons on Newton's hypotheses. Okay, so the theory-hypothesis distinction. We'll start with Newton's first paper, where he introduces a new property of light that he's discovered. That's the property of refrangibility. So this is the property of a disposition that any given light ray has to refract. The experimental setup involved a prism, and light entered the prism and was transmitted through it. And what Newton found was that the light refracted to different degrees, and it produced an elongated image. And so this had revealed to him this new property of refrangibility. So he decided that, well, he concluded from that white light is a heterogeneous mixture of rays of different refrangibility. He then mapped refrangibility to color. And so each different colored ray had a different refrangibility. And so he explained the colored spectrum by saying that, that the colored light had always been in the white light. White light is composed of rays of different colors. And because they all refracted differently, they were able to, the prism had the effect of kind of grouping the colored light into its homogeneous groupings. Okay, so he made an argument roughly like this, where he concluded that white light is composed of rays of every refrangibility. Then he argued that there's a one-to-one correspondence between refrangibility and spectral color. And finally, he concluded that white light is composed of rays of every spectral color. Okay, so we get that, we get all that experiment, and of course the details are much more complicated than this, but in the process of developing this theory of light and color, we get an epistemic distinction in Newton's first optical paper. So he gives us two kinds of claims. The first kind of claim is like the ones I just gave you. White light is a heterogeneous mixture of rays. And of that kind of thing, in particular, the claim that white light is a heterogeneous mixture of rays of different refrangibilities, he says, for what I shall tell concerning colors, it's not a hypothesis, but most rigid consequence, not conjectured by barely inferring, 'tis thus because not otherwise, or because it satisfies all phenomena, but evinced by the mediation of experiments concluding directly and without any suspicion of doubt. He also introduces us to another kind of claim. He argues that light is a substance. Of this, he very quickly shies away and says, I shall not mingle conjectures with certainties. And so we have two kinds of claims. One of them, he labels hypothesis. The other, well, he doesn't actually call this a theory at the time, but the term theorem gets used later on to refer to this kind of proposition. So I think I'm safe in giving this in considering this a distinction between theories and hypotheses. So theories are things that are propositions that are demonstrated via observation and experiment, whereas hypotheses are propositions that are acquired via speculation. Theories are certain. Hypotheses are not certain. At best, they are highly probable or plausible. And finally, theories tend to concern observable, measurable properties of the phenomenon, whereas hypotheses tend to concern the nature of the phenomenon, although sometimes we find that hypotheses that don't, that aren't doing metaphysical work, but something else. But anyway, we can talk about that later. Okay, so Newton claims later on, when he's taken to task by Hooke, Pardies, and Huygens, he claims that he never intended to introduce a hypothesis. That was never supposed to be part of the explanation that he was giving. He writes, "But to examine how colours may thus be explained hypothetically is besides my purpose. I never intended to show wherein consists the nature and difference of colours, but only to show that de facto they are original and immutable qualities of the rays which exhibit them." In other words, he was trying to offer a theory rather than a hypothesis. His claim is that he started from experiment and he had arrived at certainty. And that thing that he knew with certainty was the theory. But of course, there was a hypothesis there. And that's what I'm interested in, is what role that hypothesis was playing in this trajectory from experiment to certainty, if any. Okay, so I'll start with what hypotheses are not allowed to do, according to Newton. I won't provide much evidence for these claims, but we can talk about where these claims come from in question time if you want to. Okay, so firstly, hypotheses aren't allowed to constrain our theorizing. So the advice that Newton gives us is that if we're going to hypothesize, we should be reading our hypotheses from our theory. The constraint on hypotheses needs to be what the phenomena and what the theory tells us is true. We shouldn't be, allowing our theories to constrain. We shouldn't allow our theories to be constrained by hypotheses. And the second thing that hypotheses aren't allowed to do is that they're not allowed to directly influence our epistemic attitude towards a particular theory. And so we are definitely, well, sorry, to put that another way, to the extent that hypotheses do influence our epistemic attitude towards particular theories, they're only allowed to influence them indirectly. And so hypotheses can make a theory more plausible or more compelling to accept, and that kind of thing. But it's not allowed to provide, it's not allowed to be seen as evidence or something like that. Newton explains this. He says, "Should anyone conjecture from the possibility of a hypothesis to the truth of things, I cannot see how they would be able to determine certainty in any science, since numerous other hypotheses can always be invented, which shall seem to overcome new difficulties. And for this reason, I place aside improper arguments from the contemplation of hypotheses." He kind of echoes this kind of statement later on in this comes from a letter to Coates that he wrote around 1713. He writes, "One may suppose that bodies may, by an unknown power, be perpetually accelerated, and so reject the first law of motion. One may suppose that God can create a penetrable body, and so reject the impenetrability of matter. But to admit of such hypotheses in opposition to rational propositions founded upon phenomena by induction is to destroy all arguments taken from phenomena by induction and all principles founded upon such arguments. And therefore, as I regard not hypotheses in explaining the phenomena of nature, so I regard them not in opposition to arguments founded upon phenomena by induction, by principles settled upon such arguments. In arguing for any principle or proposition from phenomena by induction, hypotheses are not to be considered. The argument holds good till some phenomenon can be produced against it." Okay, so, that transition happened pretty quickly. So then Newton offers a bunch of things that hypotheses can do. First, this kind of becomes clear in his hypotheses paper that Araign's already talked about, his 1675 paper, where he writes, "I have observed the heads of some great virtuosos to run much upon hypotheses, as if my discourses wanted a hypothesis to explain them by, and found that some, when I could not make them take my meaning, when I spake of the nature of light and colours abstractedly, have readily apprehended it, when I illustrated my discourse by a hypothesis." Okay, and so he tells us that hypotheses are allowed to explicate or illustrate theories. And so this kind of way of using hypotheses is likely to make a hypothesis more intelligible or more compelling to someone to accept. But again, if they're used in this way, they're not to be used as evidence. But of course, Newton also recognizes that just because a hypothesis fits with a theory, just because it kind of does a good job at illustrating the theory, that doesn't mean that that hypothesis is likely to be true. We shouldn't take that as kind of evidence for the hypothesis. He explains this by saying, I knew that the properties which I declared of light were in some measure capable of being explicated, not only by that, but by many other mechanical hypotheses. In other words, hypotheses tend to be underdetermined by the theories. He also offered a second role that hypotheses can be used for. And this quote comes from what I think of as the queries paper that Newton wrote in 1672, where he sent Oldenburg a list of 8 queries that were then published in the Philosophical Transactions relating to light. He writes, hypotheses ought to be brought forward only to explicate the properties of things and not to be assumed in determining them, except insofar as they may furnish experiments. In other words, hypotheses are allowed to be employed to help reveal new phenomena. And so hypotheses can be used to generate research programs. And we see this, for example, in the queries at the end of the optics. In that case, the function of a query seems to be to bring hypotheses into contact with the empirical world. And so, for example, hypotheses can be used to help suggest new experiments. Okay, so what's important about, in my opinion, about the way that Newton is thinking about hypotheses and the way he uses them, especially in his early optical work, but I think later as well, is that one needn't believe in the working hypothesis. You can have a hypothesis, and it certainly doesn't need to be true in order to be using it for the purposes that he thinks it can be used. And so, for example, we see him use a hypothesis that he doesn't believe in. He uses Hooke's hypothesis in a way that I think is representative of how he uses hypotheses more generally. So we'll just digress briefly so I can show you what I mean. In a letter to Oldenburg, where he's responding to Hooke's argument, Hooke's objections to his early optical paper, first optical paper, Newton writes, I shall now in the last place proceed to abstract the difficulties involved in Mr. Hooke's discourse, and without having regard to any hypothesis, consider them in general terms, and they may be reduced to these 3 queries. 1, whether the unequal refractions made without respect to any inequality of incidence be caused by the different refrangibility of several rays, or by the splitting, breaking, or dissipating the same ray into diverging parts, whether there be more than 2 sorts of colors, and 3, whether whiteness be a mixture of all colors. Now, in the context, what Newton has done is taken Hooke's hypothesis and tried to generate empirical consequences for it. And so I'll show you what happens with the first query. So what happens here is that he sees that he and Hooke can make different predictions about what happens with the experimentum crucius. Okay, so we start out the same way. Hooke and Newton agree that, that what is to be expected when you put a beam of white light through a prism is that you should get an elongated spectrum. But they disagree about what you'd expect to happen, at least as far as Newton is concerned. They disagree about what we should expect to happen when we narrow down that beam of light and we just take one small part of that spectrum and put it through a second prism. Okay, so according to Newton, what we should expect is that one ray of light should just refract the same way that it did at the first prism. So there shouldn't be any elongation, no scattering of the spectrum. Whereas Newton thinks that on Hooke's hypothesis, what we should find is another elongated spectrum at the end of that, after that second prism. And of course, what Newton finds is what his prediction supports. We don't get what he what he articulates, what he takes to be Hooke's prediction. It's really complicated to say that. And I'm not sure that Hooke would agree with Newton about what Hooke's prediction in fact was, but this is how Newton presents it. Okay, so some things that we note about this case. Newton uses Hooke's hypothesis to generate effectively a series of crucial tests, and I showed you one of them. And so Hooke's hypothesis, even though Newton doesn't believe in Hooke's hypothesis, doesn't agree with it, Hooke's hypothesis is able to provide a temporary platform from which he's able to conduct an experiment. And it doesn't seem to matter that, as far as Newton was concerned, the hypothesis was false. So I think we find another similar case in Book 2 of the Principia, where Newton uses the vortex hypothesis in a similar way. In both cases, the hypothesis scaffolds an empirical inquiry. All of this is not to say that hypotheses are all equally acceptable. We can rule out certain hypotheses by appealing to experimentally established properties, features, and processes on the grounds that those hypotheses cannot support those properties, and so on. The hypotheses need to at least, as Hooke would put it, save the phenomena. But that's not really much of a restriction. Okay, so one needn't believe in the working hypothesis. Another thing that we learn about hypotheses is that they are supposed to be temporary. That is, they have a role to play, supporting natural philosophical inquiry, but they are not part of the content of theories. That is, Newton's theory of light and color cannot be said to include the corpuscular hypothesis. This is a separate thing. And so finally, the final product, the theory, should be cleansed of all hypotheses. Hypotheses should only be used in the kind of working out phase. Okay, so that's the theory hypothesis distinction. Now I'm going to give you a case of how Newton puts corpuscles to use. Okay, so we'll return to this diagram here and Newton's theory of light and colors. In his earliest paper, Newton argued that light is a substance, as I said earlier. So here's how this kind of worked. I'll give you a quote from him. He writes, this is after he has laid out his theory of light and colors. He says, these things being so, it can no longer be disputed whether they be colors in the dark or whether they be qualities of the objects we see, no, nor perhaps whether light be a body. For since colors are the qualities of light, having its rays for their entire and immediate subject, we can think those rays qualities too, also, unless one quality may be the subject of another and sustain another, which in effect is to call it substance. We should not know bodies for substances, were it not for their sensible qualities, and the principle of those being now found due to something else, we have as good reason to believe that to be substance also. Okay, so what Newton is telling us here is that the color of bodies, the color that we perceive, say, when we're looking at a blue chair, is not coming from the chair, but from the blueness of the light that's reflecting off that chair. And so Newton thinks that since one of the ways that we know that that chair is a substance is because of its sensible properties, that is, like its blueness, since that blueness is in fact coming from the light, that should make us think that light is a substance also. He also tells us that because light has properties, we should think of light as a substance, just kind of appealing to the substance quality or substance property distinction. Okay, so just to summarize that again, Newton thinks that since color is a quality or property of light, we should consider light to be a substance. And also, since we recognize substance by its sensible qualities, such as color, we should recognize light as a substance. Some things to note about the way that Newton kind of characterizes light as a substance here. He's working with a very thin notion of substance. He's not reading anything else into that notion of substance. It's just substance by virtue of the fact that it has properties, and two properties in particular. So substance is simply the thing that sustains or supports properties. It is the thing that ties a group of properties together, making them properties of something. And light performs the substance role with respect to color properties, which is to say light is a substance in that it supports color and also refrangibility. And Newton doesn't seem to use this idea of light as a substance to attribute any properties to light beyond the ones he's already empirically established, that is refrangibility and color. Okay. So coming back to this theory of colored bodies, because this is where things start to get a bit more tricky for Newton. So I've already said his theory of colored bodies is that bodies acquire their color or appear certain colors by virtue of the color of the light that is reflecting from them. And Newton wanted to kind of understand this. He wanted to develop a theory of colored bodies based on this. So Newton thought that if he could explain interference phenomena, that is the phenomena that you can see in those images below, then he would be able to explain how bodies reflect particular colors. And so he started looking at these, what are now known as Newton's rings. His basic insight that light has inherent properties of color and refrangibility wasn't enough. That couldn't explain how it is that some of the light was absorbed or transmitted into the chair and some of it was reflected. And so he developed his hypothesis a bit further. Okay, so now the hypothesis became a bit more robust. It wasn't just that light is a substance, although that was part of it. So basically, there are kind of three parts to the hypothesis that Newton began working with at this point. There's an ethereal medium. So ether is a thing that fills empty spaces, including the pores of solid substances. Ether vibrates, it carries sounds, sense, and light, and so on. And this is, and these vibrations are kind of used to explain various different things. And the vibrations differ in size, and this causes different sensations. There's also light. So light is separate to the ether. Light is a substance that's propagated from lucid bodies, so shining bodies, and it travels through the ether. And he considered, and Newton thought that that light kind of could be kind of grouped into somehow into smallest parts that he referred to as rays. And the rays of light, the smallest parts of light, are physically heterogeneous, and so they differ in size, shape, and velocity. And this accounts for their observable properties. And the final aspect to this is that light and ether interact. So light warms the ether and the ether presses on light, and together they kind of are responsible for various optical phenomena. And here's kind of how Newton characterized the separation between light and ether. He writes, "I suppose light is neither this ether nor its vibrating motion, but something of a different kind, propagated from lucid bodies." Okay, so in Newton's these interference experiments, Newton discovered a new phenomenon, periodicity. So basically, he kind of starts, at least the way he describes it, when he kind of talks us through the experimental procedure in the optics, is that he starts with basically two prisms and he kind of mashes them together and notices that you can get this optical phenomenon that Hooke had talked about in micrographia, these rings. And he kind of noted that when you press the two prisms together really hard, such that right in the middle, the two surfaces are absolutely pressing together without any air or space in between, you get a black hole. You get kind of a spot without any color or light in it. And so he started to kind of explore this further, and eventually he kind of got a glass plate and then a glass lens, and set them on top, as you can kind of see in this image here. And he found that he was able to get very, very regular rings of light sitting on the top, appearing on the top. So, and he drew what he saw. So we see him drawing various different kinds of diagrams, trying to kind of capture and measure what is going on in these kinds of ring experiments. What he eventually realizes is that the diameter of each ring was proportional to the thickness of the air or the thickness of the film between the two surfaces. So he talks about there being a thin film between the surfaces, which is the air. And so he thinks that that gap is proportional to the rings. Okay, he does a lot of experiments where he looks at all different sides of these of the experimental apparatus, and he starts to kind of carefully try and document what colors you see on the different sides. And so you can see in this diagram here that he's kind of written carefully what the different colors are. What you might notice is that when you see, say, I assume you can see my pointer, if you can see, say, red on one side, on the top side, you wouldn't see red on the bottom side of that point. And when you could see, say, green on the top side, you couldn't see green on the bottom side, and so on. And so Newton started to kind of develop an idea about what this periodic reflection and refraction was going to start to look like. To get clearer on this phenomenon, though, he tried another kind of experiment. He got some. He kind of created homogeneous light and started shining homogeneous light of different kinds onto the top of that surface. So, for example, when he shone red light on the top of the surface, he found that he just got a bunch of red rings. And when he shone yellow light, he just got yellow rings, and so on. And the thing about these was that they were very regular, and it was very easy, and it made the rings very, very visible for him. And of course, he was able to look on the underside as well. And so he started generating diagrams that looked like this. So here we get a much clearer image of what Newton is kind of pushing towards, what he's discovering in these experiments. We get this periodicity where you've got light alternately reflecting and refracting. It never reflects and refracts at the same time. It either goes through to the bottom, it either travels through both of the glasses, or it is reflected and bounces back. And here's how he describes it in the optics. He says, and from thence the origin of these rings is manifest, namely that the air between the glasses, according to its various thickness, is disposed in some places to reflect and in others to transmit the light of any one color, and in the same place to reflect that of one color where it transmits that of another. Okay, so we'll come back to this diagram again. So Newton still wanted to kind of explain what that periodicity was about, how to explain that phenomenon. And so at this point, he kind of turns to his hypothesis, his ether hypothesis, and he kind of imagines the light kind of hitting the ether, kind of like stones hitting a pond or drops of water falling into a pond. And he imagined the kinds of ripples and vibrations that it would cause. And he thought, well, maybe light is kind of creating vibrations in ether in the same kind of way. And he suggested that this kind of vibration, we might refer to it as a pulse. So then he kind of mixed his metaphors maybe a little bit, and started thinking about, say, these pulses or vibrations as kind of waves or something like this. So if you've ever been in the water, in the ocean, you might know that, well, if you've ever tried surfing, you'll know that if you're lucky enough to catch a wave, you'll get brought all the way into the shore. You can just ride that wave the whole way in. But if you don't catch a wave, or if you get unlucky and get caught in a rip, or the tide's going the other way, it's quite hard to come into the shore, and you'll get swept out the other way. So Newton started to think, well, maybe this is how light works. Maybe light kind of gets caught and travels with vibrations or pulses, or maybe it ends up kind of getting caught and having to travel against the vibrations, and so on. And so what Newton wanted to say was that this concept of a pulse, we can now define the pulse as the period or distance between the expansion and contraction of a pulse or a wave. And so then he decided that if there was one pulse of a vibration, then the light would be reflected. If there were two pulses, then that would lead to transmission. 3 pulses would be reflection, and so on. So he started to kind of operationalize this idea of a pulse. He sort of turned it into a unit of measurement. And so each color excites pulses of a different length, which is why light is transmitted or reflected at different points. There was just one problem with this whole thing. How do you detect a pulse? I mean, this is a hypothetical phenomenon in an undetectable medium. So how is he going to do this? Well, so Newton thought that the pulse was indicated by the regularity of the phenomenon. So the distance of the pulse, or the size of the pulse, length of the pulse. So if we come back to this kind of diagram again, and I already said that the diameter of the rings was proportional to the distance between the two surfaces. Well, what Newton noted was that right at the very center, where the two surfaces absolutely touch and there's no gap between them, the light is transmitted through. And so then he decided, what he noticed was that he concluded that the smallest ring of light that you can see closest to the center indicates the smallest gap required for reflection. And given that he knew the size of his spherical lens, he was able to calculate what size gap he was looking at there. And so that gap gave him the length of one pulse. And a pulse became a unit of measurement. And so he then realized that reflection occurs when the distance equals 1,357, etc. pulses, and that transmission occurs when the distance equals 2, 4, 6, 8, etc. pulses. And so what we see here is that Newton took a vague metaphysical concept that was neither observable nor measurable directly, and attaching it to an empirical effect clearly defined it. Okay, so now we need to look at what happens, because we certainly don't get discussion of pulses in the optics. We get something else. And so I'll just give you a quick rundown of what happens, because in this stage, what Newton kind of needed to do was to extract the hypothesis from the theory in keeping with his methodology. So in 1665, in various papers, we find him thinking about a pulse in a vibrating medium when he's doing his optical work. And I'll do this very quickly. So in 1675, we see again this similar kind of concept. Here we see Newton thinking about the vibrations as waves that are condensing and expanding and so on. So we've still got this same kind of concept here. In 1690, when Newton was putting the final touches on, well, he was producing what was going to be his optics, we find vibrations being talked about there. So the vibrations excited by the more refrangible rays are shorter than those excited by the less refrangible ones. And then there's kind of a gap here. So Newton didn't publish that version of the optics. There is various speculation as to why he decided not to publish this version. But one of the reasons is most likely that he wasn't happy with his theory of pulses, because he hadn't managed to extract the hypothesis from it, and it was still very kind of hypothesis loaded. But no matter what the reason, eventually in 1704, we get the published version of the optics. And what we find is a very interesting proposition 12 in book 2, where Newton writes this. He writes, every ray of light in its passage through any refracting surface is put into a certain transient constitutional state, which in the progress of the ray returns at equal intervals and disposes the ray at every return to be easily transmitted through the next refracting surface and between the returns to be easily reflected by it. I mean, this is completely clear and obvious to you what this means, right? People really struggled to understand what Newton was talking about at the time. I mean, we might have a better grasp on what is going on in this proposition because I just explained to you what the hypothesis was that was kind of underpinning it. But it wasn't very clearly explained. And Newton seems to have recognized this, because then what we find is is this passage where Newton writes what kind of action or disposition this is, whether it consists in a circulating or vibrating motion of the ray or of the medium or something else, I do not here inquire. Those that are averse from assenting to any new discoveries, but such as they can explain by a hypothesis, may for the present suppose that as stones falling upon water, put the water into an undulating motion, and all the bodies by percussion excite vibrations in the air, so the rays of light by impinging on any refracting or reflecting surface excite vibrations in the refracting or reflecting medium or substance, and by exciting them, agitate the solid parts of the refracting or reflecting body, and by agitating them, cause the body to grow warm or hot, and the vibrations thus excited are propagated in the air for causing sound and move faster than the rays so as to overtake them, and so on. So he goes on, and what we're seeing here is basically that hypothesis that I told you about before. But notice here, he's describing it as a hypothesis, and it's being introduced here to illustrate the theory or explain the theory to make it more compelling or intelligible. And he immediately, after he's described that hypothesis, he says, but whether this hypothesis be true or false, I do not here consider. I content myself with the bare discovery that the rays of light are by some cause or other alternately disposed to be reflected or refracted for many vicissitudes. And then to really signal the end of this discussion, he introduces a definition. The returns of the disposition of any ray to be reflected, I would call its fits of easy reflection, and those of its disposition to be transmitted, its fits of easy transmission, and the space it passes between every return and the next return, the interval of its fits. So this interval of fits then becomes the focus for the rest of the optics. Newton spends the rest of the time kind of trying to articulate how we might measure the interval of the fits and what use we can put this to. And it turns out to be an extremely predictively successful account. There's this theory of fits. And so it's kind of surprisingly useful in a lot of ways. Okay, so I'm going to wrap up there briefly with some lessons on Newton's hypotheses. Okay, so this started out as a talk about the corpuscular hypothesis, but I think it kind of morphed into a talk about the ethereal vibrations. And so let's start though with the corpuscle and substance ideas. So corpuscle and substance are functionally defined, we said, and in some contexts, a corpuscle is a thing that sustains qualities, while in other contexts, a corpuscle is something that can excite vibrations in a medium. So in short, Newton's hypothesis, in Newton's hypothesis, to be a corpuscle is to play a certain kind of role. It doesn't seem to kind of pack very much metaphysical baggage. In Newton's optical investigations, however, ethereal vibrations seem to be the things doing the heavy lifting. And what we saw was that ethereal vibrations played two roles with respect to Newton's theory of fits. First, we saw that in the optics, Newton introduced the hypothesis to explicate his theory of fits, and it kind of offers a possibility proof. As a possibility proof, this satisfies critics and it helps to make the theory more compelling. And in his optical inquiries, we saw that Newton used the hypothesis of ether to posit a physical cause for the observed pattern of colored rings, an ethereal pulse. And he operationalized the notion of an ethereal pulse, and we gained a unit of measurement in the process. Importantly, neither of these roles requires epistemic commitment to the hypothesis. And I'll leave it there. Thank you.
Thank you very much. Just a moment. There we go. If there are any questions, if you could please raise your hand in the chat. Daria.
Yeah. Hi, Kirsten. Nice to see you. It's very nice talk and very clear. And so maybe I have a question more of sight. Speaking about difference between theories and hypotheses. You were talking about natural philosophy. And what about natural theology? What is the epistemic status of claims about, for example, God's existence, which we can observe or deduce from natural order? Thank you.
Yeah, that's a good question. My view on this, I don't know, might be a bit unpopular, but I think that for Newton, he takes God as a given. This is not open to question, and so I think that he thinks that we can we definitely learn about God from studying the natural world, and we can and so I think that what he kind of thinks that we do is that I mean our main source for knowledge of God is scripture. For Newton, we should be reading scripture. And then we also learn about it, from the natural world. Yeah, I don't know what else to. I'm not sure that I have anything very. I set that up as being controversial, but actually, I don't think that much is very controversial. I think that Newton takes scripture to be kind of on a par with experiments of the natural world, and so these are kind of two very reliable ways of learning about God. Yeah.
Okay, Adrian Curry.
Thanks. Those are such great slides. I wonder, so you said at the start that you sort of saw your talk as being kind of in dialogue with Ariane's one, or at least building on it or something like that. And I'd really love for you to sort of build out what you see the sort of connections being between them, in the sense that, I guess, in a sense, Ariane's was focusing on sort of the way that she put it, at least, was the sort of content of the hypotheses, and you seem to be very much interested in the sort of function in some way. And so I wonder if you could just bring those things into dialogue for me and see how you think they kind of build on each other, or what ways their tension, things like that.
Sure. I haven't thought very much about exactly how my views on the roles of hypotheses work in relation to Araine's position, but I'll have a try. Araine's might be able to tell me whether this seems plausible, I guess. Okay, so Araine's is kind of listing some criteria for permissibility. So one way of thinking about permissibility then would be to think, so permissible for usage in this kind of experimental context. So certain hypotheses are going to be kind of better or worse for this kind of, work. And so some of the, and I'm just trying to think I don't have them written down in front of me, all of Araine's criteria, but we have things like parsimony, where we want to be able to kind of use, we want to kind of postulate fewer processes or causes or kind of mechanisms in the world, or at least ways that things operate or something in the world. And so, of course, on the kinds of hypotheses that Newton seems to like for doing this kind of work are ones where they're kind of, where he can see kind of analogies across nature in different ways. So he really seems to like the idea of a vibration in the ether, because we see vibrations in all kinds of fluids, and we see vibrations in the air and so on. And we've got kind of all these experiences of vibrations. And so this is something that, seems safe to kind of postulate and at least use in this kind of context. I mean, the experimental criterion, I think, is a pretty obvious why Newton, why on Araine's view, Newton wants our hypotheses to kind of carry the right kind of, have the right kind of relationship to the world. We want them to be able to, we want to be able to kind of use them to come up with new experiments and things like that. I think maybe where Araine's and I differ is that I don't think that hypotheses do that directly. I think there's kind of, I think that actually what we see, and I think maybe, who was it? I think Michael maybe suggested something that maybe I agree with in this sense, or I'm not sure, you might not agree with me, but that basically what we see is when a theory is being, when a hypothesis is kind of being brought into contact with the world, when the empirical consequences of a hypothesis are being kind of teased out, what we see is that that's kind of, that's being stated as a query. And so queries are kind of the thing that provide us with that kind of connection between a hypothesis and experiment, things like that. Yeah, I'm not sure which other what other criteria I can speak to off the top of my head, but yeah, maybe that I'd be curious about what Arends thinks about that. Although I'm probably putting you on the
Arends,
spot.
do you have a comment on that?
I think what you said makes sense. There are, some overlapping, and there are, some places where we do kind of diverge. And I think you hit all those spots. Yeah, thank you.
Okay, Vincenzo De Risi.
Yes, thank you very much for the talk. So I have a question for you and possibly also for Arends. That is to say, both of you have tried to pinpoint some of the features of Newton's hypothesis. My question is purely historical. That is to say, do you think there are clear sources for Newton's use of hypothesis in this sense rather than others? I may add just to emphasize something that cannot work. In Aristotle, hypotheses are completely different things. That is, are principles which are certain, cannot be doubted. They are not conjectural at all. They are a kind of axioms. Then if you take the whole Aristotelian and scholastic tradition, this conception of hypothesis is carried on. And even if you look at ancient mathematicians, that could be an important source for Newton, of course. Archimedes takes hypothesis in the floating bodies, for instance, as something which is clearly the case. That is nothing conjectural at all. Even though Archimedes himself in the Stand-Reckoners called hypothesis the heliocentric system, which might be a conjecture for him, but I mean, this is not clear. So given that Newton could not rely, I think, on these classical sources or on scholastic tradition, do you think there is anything else, Francis Bacon, the astronomical tradition, anything at all that could bring him to conceive hypothesis in that way?
Yeah, I tend to look at this. I mean, obviously Newton's got all sorts of different kinds of influences on him, his being kind of educated in a roughly Aristotelian tradition to begin with. But at some point, fairly early on as a student, I think he kind of encountered the work of the Royal Society and, the Baconian experimental philosophy. And there you just get hit with all this rhetoric about, being anti-hypotheses and speculation and fancies and all this kind of stuff. And, we don't want to be doing speculative philosophy. We don't want to be kind of building castles in the air and all that kind of stuff. And the target of all that early rhetoric really seems to be the scholastics. And so you see Newton kind of picking up a lot of this rhetoric. Like, this seems to be where it comes from, at least in his optical work. I think that is kind of what he's talking about at that point when he said when he's trying to avoid hypotheses. It gets a bit more complicated, I think, when he publishes the first edition of the Principia, where we get a list of hypotheses at the start of book 3. And of course, to any kind of astronomer reading that book, that wouldn't be surprising, especially given what you find hypotheses in Huygens's book and so on. So in that first edition of the Principia, I think he's using hypotheses in more that astronomical sense. What's interesting then is that by the time you get to the second edition of the Principia, he then relabels all of those hypotheses as phenomena and rules, and a couple of them remain hypotheses, but they kind of get buried in the text. And if you take Coates's preface seriously as maybe something that Newton would kind of assent to at that point, he's kind of reframed the Principia that was kind of just a standard, I guess, astronomical text, maybe in the first edition, or but in the second edition, it becomes a kind of a demonstration of experimental philosophy, where suddenly you're supposed to be avoiding hypotheses, and you're kind of, there's a big emphasis on the kind of on the phenomena, reasoning from the phenomena. And so there's a kind of an interesting shift there. So that I think that, and so I think what kind of happens there is that the way that Newton is using hypotheses in the Principia then kind of gets brought into line with the way he's trying to use them in other places, like the optics. So anyway, that's my view on what is going on there.
Okay, thank you.
Okay, we have 2 questions and about 5 minutes. So if you could keep them moderately short, both the questions and the answers. I'm sorry, Terry Bristol.
Okay, thanks. So very quickly, one, just for those of you obsessed with this issue, I just happened to come across an exchange between Daniel Bernoulli and Leonard Euler. And Euler comes out with this theorem and says, this is from first principles. And Bernoulli says, nah, I don't believe it. He said, you found this empirically, and then you went back and pretended like you derived it. And he accuses, and Euler comes back, he says, well, actually you're right. Anyway, you might look at that. The other thing is that Newton's theory of gravity actually comes from Kepler, okay, which is from Tycho. And that's really interesting because that's where the empirical stuff went on. And Kepler went through, I can't remember, somebody said 47 different hypotheses trying to figure out the orbits. And Galileo, for instance, had Kepler's book saying that they were ellipses, and he just ignored it because the first principle for him was they had to be circles. Circles were the perfect thing. Well, Newton gets into that, and there's a whole thing about why did Newton accept the theory of ellipses? And first thing is he takes them from Kepler, because Kepler's already got ellipses there. There's this famous thing out there, Feynman's Lost Lecture or something like that, which is about this. And Feynman says he doesn't understand what the hell is Newton's talking about. Newton gives this argument about why they have to be ellipses. They cannot possibly be circles. Anyway, that's another just area. And he drives this theory of gravity from that. Enough.
Yeah.
Okay.
Yeah, I think that's right.
Last question, Alberto Luis Lopez.
My question is from a
Can you speak up a little bit?
Okay, sure. I hope you can hear me. Yeah. Okay, perfect. So, hopefully, my question is from a Berkeleyan perspective. Berkeley in 1709 published a work, a theory of vision, and in his work, he was considering William Briggs, Barrow, Molyneux, Newton, and so on. But from Berkeley, distance is not calculated by divergent or convergent lines, angles, rays, but by experience and habit. So my question is what is the role, in some of your slides you were talking about, you show us ethereal medium, light, ether, so it's some like external elements. So my question is, what is the role of experience?
Sorry, I missed the last bit that you just said.
My question properly is, what is the role of experience in Newton, in his conception of vision, and related to what is the role of the subject, the perceiver, in the process of perceiving and calculating distance?
Yeah, good question. I'm not sure that there's I'm not sure that there's anything kind of that interesting or special about the role of the observer or the experiencer for Newton compared to what people like compared to people like Locke or Boyle, for example. I mean, one thing that Newton is always very careful to say is that he's not attributing color to light. What color, in fact, what the property that's pointing to with light is a property to give us the experience of a color and things like that. So he's very careful that he knows that he's working with something like a primary secondary quality distinction, maybe where things like colors are, things that are, that they're the sensible qualities, I guess we might think. Other than that, he's definitely thinks about this stuff as an experimenter, and so he's concerned about kind of observer biases and things like this. And so, when he's doing, he produces a kind of a chart where he kind of overlays a spectrum onto a graph where he tries to kind of identify where the colors appear the brightest at different points. And he purposely gets an assistant to draw the lines because, he kind of has an idea in his mind about what he's aiming for here. And he doesn't want, and he doesn't want that to kind of bias what he in fact sees and the results he gets. I don't think in such a short space of time I have anything else interesting to tell you about that, but he's definitely not doing anything like Berkeley. I don't think. Yeah.
Oh, thank you.
Well, thank you, Kirsten. And thank you both, Kirsten and Lorenz, for a lively afternoon. 2 wonderful talks, a lot of great discussion. And we hope to see you all next week when there is going to be a panel discussion on skepticism and the passions in Hume's philosophy. But thank you very, very much.
Thank you, Dan.
Thank you.